All right, let's take a look at our lesson on multiplying and dividing rational expressions. The first thing that I would like to really talk about and point out is the difference between the way this rational expression looks versus this one. Okay, we handle these two rational expressions differently when we're multiplying and dividing. Let's talk about why. What are we doing? So this kind has no pluses and minuses, right? There's no pluses and minuses in there. So the way that we simplify that type is just reduce, just like reduce a fraction. So we reduce the fraction. An example of that would be like 2/4, right? We reduce 2/4. We know 2 goes into each of those. That would be 1/2. So if there's no multiplying and adding and subtracting inside of this numerator or denominator on any of the numerators or denominators, we're just going to simply reduce. That's what we're going to do. Whereas this one, notice that this rational expression has subtractions, adding and subtracting in them. This is done completely differently. So if we do have adding and subtracting inside either a numerator or denominator of any of the fractions, what we need to do is we need to factor, then reduce. Many times we can cancel out factors. For example, here's an example. If we would factor, say, and we got x plus 1 over minus x minus 2 over x minus 2. Let's say we got that. We factored and we got that. See how this factor is the same as this factor, and they are factors. Remember, factors means things that are being multiplied together, and sometimes I call those bubbles, but at any rate, factors. So what we would do, we could cancel those factors out. Okay, so that is the main difference, and I know students get really confused about what to do, whether you're adding, subtracting, multiplying, etc. So that's what we need to keep it in mind. So let's look at, let me get rid of this. Let's look at our first example. Notice that we have subtraction in the numerator and denominator, so we're going to have to do factoring. So in the numerator, let's see, we have a GCF, looks like, of 2x squared, a greatest common factor of 2x squared. When I factor that out, remember factoring means dividing, and so if you want to do scratch work over here, sometimes we can do this in our head, but if this is kind of confusing, so we would take the 8x cubed and divide that by 2x squared. See, 8 divided by 2 is 4, x cubed divided by x squared is x, and then we would do the negative 2x squared divided by 2x squared. Let's see, 2 divided by 2 is 1. X squared divided by x squared is 1. And so that's what we have in the numerator when we do our greatest common factor factoring. As we see in the denominator, we also have a greatest common factor in the denominator. That greatest common factor is x. So factoring, remember, means dividing, so I'm going to divide. Let's do more scratch work over here. So I have 8x squared. I'm going to divide it by x. Let's see, 4 divided by 1 is 4. X squared divided by x is x. And then I'm going to do x, negative x divided by x. And let's see, that leaves me a negative 1. So then we step back and we look to see what we have, and we notice that we've got two factors that are exactly the same. That means that that would be like 2 over 2 is 1. Basically, that turns into a 1, and I can get rid of that. So yay, we got rid of one factor. So let's keep looking to see if there's anything else we can reduce. Let's see, let's do our scratch work over here. So x squared divided by x, we know we have 2 x's in the numerator, 1 in the denominator. That means we have 1 x left in the numerator. So our final simplification turns to be 2x. Okay. All right, great. So let's look at the second example. Notice I don't have any adding and subtracting in the second example. So what we can do is just straight up simplifying, like reducing fractions. Okay, so let's see, what do we have? We've got, well, 8 and 12 have a common factor of 4. So if let's see, so that leaves me, if I divide 8 by 4, I get a 2. I divide 12 by 4, I get a 4. Okay, so, oops, 12 by 4, I'm so goofy, is a 3. Okay, that's the numbers. So let's see if we have any other common factors. Looks like 14 and 26 have a common factor of 2. So why don't we do that? 14 divided by 2 is 7. 26 divided by 2 is 13. And I don't have any more common factors. So what I want to do, so this doesn't get too confusing, I just want to rewrite it. So we've reduced the numbers. So we've got 2x cubed times 7y to the 4th all over 13xy times 3x squared. Okay, so now let's look at our next scenario. So we can multiply straight across the top. That is fine. To make this look a little simpler, there's a big mess going on there. So let's just clean that up. 2 times 7 is 14. X cubed times y to the 4th. Okay. And then we've got 13 times 3 is 39. X times x squared is x cubed. And then I have a y. All right, so that's a bit cleaner. Let's see what we have now. Oh, look at there. We've got this x cubed over x cubed. That's 1, right? It's the same over itself. That's 1. Okay, that's helpful. Then I've got, what do I have? I've got 4 y's. You can think about, let's just do our scratch work again. I've got 4 y's in the numerator and 1 in the denominator. So I can do that. That's y over y is 1. So that leaves me 3 y's in the numerator. So I've got 14y cubed over 39. And that's my simplest form. Okay, so that's the technique that we use when we don't have any adding and subtracting in the numerator or denominator. All right, let's move to our next example. And so here, I've got adding and subtracting, so I'm going to have to factor. Yay, I know we love factoring so much. So I'm going to focus on this first fraction first. This has 1, 2, 3 terms in the numerator, so I'm going to factor like FOIL. This back sign is negative, so my signs would be different. Let's see, so 2x squared, let's see what we would do. X times 2x, or vice versa. We're not sure. We're just doing our guess and check. 3, the only way to get 3 is 1 times 3. So let's see, what would we do? Let's try a 1 and a 3. So let's check it out. So x times 2x is 2x squared. That checks. 1 times negative 3 is negative 3. That checks. Now let's do outside, inside. A positive 2x times a negative 3x. Oh, that does give us a negative 1x, so we did that correctly. All right, in the denominator, we just looks like we have a greatest common factor of x, so let's factor that out. Okay, great. So we got the multiplying. Now let's look at this numerator. Oh, we got another greatest common factor of x. Great. That's done. And it doesn't look like negative 2x plus 3. There are no common factors. I mean, I guess I could factor a negative 1 out. That might be promising since that's a positive 2x and that's a negative 2x. Well, let's do that. Let's factor a negative 1 out, and that leaves me 2x minus 3. Okay, so let's see if we have anything that cancels. You know, that's 1. I've got here, we've got, what do we have? We have x plus 1 and x plus 1. Okay, those go away. All right, that's good. Let's see, we can also, since this is multiplication, we can cancel across the multiplication. For example, what I mean is this x, which is in the denominator, I can cancel with that x, which is in the numerator, and that's okay because the numerators are just all being multiplied together, as are the denominators. So I can do that. I can look at the other fraction's numerator. So that's great. Let's do that. So that's gone and that's gone. What else do we have? Oh, look at here. We've got a 2x minus 3 and a 2x minus 3. Great. Oh, we're making such great progress. Isn't that so fun? Whew, okay, so it looks like the last thing, we don't have anything else to cancel, so let's write down what we have left over. X plus 1 over negative 1. I mean, you could certainly leave it like that if you want to, but there's an easier way to write that. We actually could divide x and 1 by negative 1, and we would just simply be left with negative x minus 1. And so that's the simplest way to leave that. All right, great. So let's look at our second page. A few more examples to go. Oh, division. Okay, let's remember back to our middle school days where we learned to divide fractions. Remember that? Where instead of dividing, we would much prefer to multiply by the reciprocal. Remember that? So remember when we were doing, say, I don't know, 3/4 divided by 1/2. We really don't want to divide fractions, so instead we would do 3/4 times 2 over 1. Okay, yay, that's way easier. That would be 6 over 4, and then we would reduce that, right? So that would be 3/2. So that's the kind of concept that we're talking about here, but these aren't just simple numeric fractions. They're, algebraic fractions. So same concept though. The very first thing that we want to do is we want to change the division problem to a multiplication problem. I mean, do that before you do anything else. So let's rewrite it. So we have 3x minus 1 over 2x cubed minus 2x times, now flip that back fraction, do the reciprocal, flip it upside down. That leaves me 2x cubed minus 2x squared over x. Okay, very good. Very good. So let's now, it's got adding and subtracting in the numerator and denominator. We don't have a choice but to factor. Yay, we love factoring. 3x minus 1. There's nothing to do on that one. Let's see, that denominator looks like we've got a greatest common factor of a 2 and an x. Okay, so let's do our scratch work over here. Our scratch work, so we've decided that 2x is our greatest common factor. So we come over here and we say, okay, so 2x cubed divided by 2x. Let's see, the 2's cancel. X cubed over x is x squared. And then 2x divided by 2x is 1. Okay, that looks good. Let's work on the second part. So I have a greatest common factor in that numerator. Let's see, what would that be? It looks like 2x squared. Okay, and you can go over and do some scratch work if you want to. Hopefully this is becoming more comfortable to you. 2x cubed divided by 2x squared leaves me an x. And then 2x squared divided by 2x squared is 1. Okay, making progress. Oh, looky here. It looks like this little guy right here we can continue to factor. That is the difference of perfect squares. So let's go one more factoring. So I have 3x minus 1 over 2x times x plus 1, x minus 1 times 2x squared times x minus 1 over x. Okay, so let's see what we can cancel out now. I see that got an x minus 1 here and an x minus 1 here. Okay, fantastic. Those go away because the same factor over itself is 1. What else do we have? We've got a 2, right? We've got this 2 and this 2, right? That's a common factor, so that's gone. And then we have 1x here and 2x here, so we do some scratch work over here. So I've got x squared over x. You know, I'm talking about x squared and x. Let's see, that cancels out. So I'm left with 1x. That goes away, and I'm left with 1x. Oh, and looky here. I've got this x and this x, and so those cancel. Whew, we're doing some great work here. All right, what do we have left? Let's see, we've got 3x minus 1 over x plus 1 left. And there's nothing else that can factor out. All right, isn't this fun? Okay, so let's look at number 5. Again, it's a division problem. First thing that we want to do is to change it to a multiplication problem. So let's rewrite it. So x squared plus 4x plus 4 over x plus 3 times, and we're going to do the reciprocal of that second piece. So it's going to be 1 over x plus 2. Okay, now we have adding and subtracting in here, so we're going to have to, do our factoring. All right, this top numerator right here, I've got 3 terms, so we're going to factor like FOIL. Can't really factor that denominator. There's nothing going on there. And there's nothing going on with that denominator. So far, we really don't have much luck in trying to cancel out anything. But let's try to factor that numerator. So let's see, that would be an x and an x. The back sign is positive, so we would match that sign. So plus and plus. I need to multiply to get a 2, to get a 4 and add to get a 4. So it looks like 2 and 2 are our best bets. So we check that out. Yep, 2x plus 2x is 4x. That works. Okay, so what do we have? We've got this matches this. So those go away. Yay. Doesn't look like we have anything else. So that's kind of it there. We are left with x plus 2 over x plus 3. All right, last one. Got one more. Ooh, this one looks fun. So, I've got adding and subtracting, so that means we have to factor. Hopefully you remember this factoring pattern from just a few days ago. We've got the difference of perfect cubes. Remember that? So that u and v thing that we looked at, u would be x and v would be 2, because 2 times 2 times 2 is 8. So then we use that factoring pattern. So that would be x minus 2, which I am sure you have memorized by now, right? Of course, I know. Yes. And then it's u squared, so x squared plus v times u, which is 2x, plus v squared, which is 2 squared, which is 4. All right, looks good. So in the denominator, we have 3 terms. So let's factor that like FOIL. So x times x is x squared. Let's see, the back sign is negative, so the signs have to be different. Okay, so we want to multiply to get 8 and subtract to get 2. Okay, so maybe a 4 and a 2 might work. Let's see, 4 times negative 2 is negative 8. Okay, that checks. So then I've got 4x minus 2x. Yep, that's 2x, so that's good. All right, so what do we have? Do we have anything we can cancel? Yeah, we do. We've got this x minus 2, x minus 2. Those are the same factor. So that's x minus 2 over x minus 2 is 1. So they go away because it's just 1. And it doesn't look like I have anything else. So we'll be left with x squared plus 2x plus 4 all over x plus 4. All right, and that is our lesson on multiplying and dividing rational expressions.